Hi class, today we're looking at Chapter 8, Lesson 8, Solving Multi-Step Equations and Inequalities. What we will learn today is how to determine if an equation has no solution, one solution, or if all numbers are solutions using distributive property, combining like terms, and having variables on both sides. When solving multi-step equations, step number 1, distribute if necessary. Sometimes combine like terms on the same side of the equal sign. Step number 2, collect variable terms on one side and constant terms on the other, using the inverse operations to change sides. Step number 3, solve. For example number 1, we have 12m plus 12 equals 6 parentheses 3m plus 3. So my first step is to distribute the 6 to the 3m and the 3. So I'm left with 12m plus 12 equals 18m plus 18. Now I can go ahead and do step number 2, collect variable terms on one side and then constants on another. So in this case, I'm going to subtract 12m from each side of the equal sign, and I'm left with 12 equals 6m plus 18. My next step is to subtract 18 from each side, and I'm left with negative 6 equals 6m. Now I can divide each side by 6, and my answer is m equals negative 1. For example number 2, I'm going to distribute the 5 times the n, the 5 times the negative 3, then 3 times n, 3 times 7. So I have 5n minus 15 equals 3n plus 21. Now I'm going to collect my variable terms onto one side and my constants on another. So I subtract 3n from each side, and I have 2n minus 15 equals 21. My next step is to add 15 to each side, and I now have 2n equals 36. Divide each side by 2, and n equals 18. Now in example 3, I'm going to distribute the negative 2 times 3r, negative 2 times 4. So now I have negative 6r minus 8. And I notice I can also combine like terms, so I can combine the negative 5r and the negative r, which is negative 6r, and bring down minus 8. So now I'm going to collect my variable terms onto one side, so I go plus 6r, and I notice that they become 0, so they both cancel out. And I'm left with negative 8 equals negative 8. And since they both are negative 8, my answer is going to be all real numbers or infinite solutions, because all answers would fit to make our equation true. So any number could be put in for r, and we will have the correct solution. Go ahead and turn your notes over to the back side now. Now, solving multi-step inequalities. A multi-step inequality is very similar to a multi-step equation. In case number 1, we've already learned that if a variable is on the right of an inequality, you must reflect the variable and the answer and switch the inequality. So for example, if I had negative 19 is less than or equal to x, I have to switch it to x is greater than or equal to negative 19, creating that reflection. Now in case number 2, this is when you have multiplication and division. If you multiply or divide both sides by an inequality with the same negative number, the inequality symbol must reverse to remain true. So as we could tell in our algebra section where we divided by a negative 6 and then the inverse was multiply negative 6, we had to switch the inequality. So it was a less than, and it now became a greater than, because you multiplied by a negative 6. The same thing where we divided by a negative 5, it went from greater than to now less than. So remember the rule where we have to do the switching if we multiply or divide by a negative coefficient. Now in our second section, we are going to solve each inequality, then graph the solution on a number line. So for part A, I'm going to distribute the 4 to the x and then the 4 to the negative 3. So now I have 4x minus 12 is greater than 6. Then I solve it just like as a typical two-step equation. I add 12 to each side, and I have 4x is greater than 18. Now, since I had to add the 12 to each side, I divide each side by 4, and I end up with x is greater than, and I can reduce this because it is a fraction, and I can reduce it to 9 over 2, or I could also say x is greater than 4.5, which is also a true statement. Now if I were to graph it on a number line, I could put 4.5, and then one less to be 4.4, one greater is 4.6. It's going to be an open circle, and the arrow is going to be going towards the right. Now in part B, I'm still going to distribute, so I distribute the 4 to the x, 4 to the 2. So now I have 3 is less than 4x plus 8. I subtract 8 from each side, and now I have negative 5 is less than 4x. Divide each side by 4, and I now have negative 5 over 4 is less than x. But because I cannot have my variable on the right-hand side, I have to do the line of reflection, and it's now going to be x is greater than negative 5 over 4. And this is actually what you end up graphing. Now you can also convert this to negative 1.25. That's also acceptable. That would also be acceptable if you wanted to graph it as a decimal format as well, so that would also be okay. So if I want to convert it to negative 1.25, that's fine. I can go, this is negative 1.26, this is negative 1.27. And again, I would have an open circle, and it is moving towards the right because it's now greater than. Now for letter C, I'm still going to distribute 4 times a, 4 times negative 3. So I have 5a minus 8 is greater than or equal to 4a minus 12. So now I can collect my variables onto one side, so I subtract each side by 4a, and I'm left with 1a minus 8 is greater than or equal to negative 12. Now I can add 8 to each side, and I have 1a is greater than or equal to negative 4. And I could divide each side by 1, or just realize that a is going to be greater than or equal to negative 4. So now all I have to do is graph that. So I have negative 4 is my center, and I have negative 5, negative 3. This time it is a closed circle, and it is moving towards the right. Now go ahead and take a few minutes to answer the 5 practice problems on your own.